Okay, good afternoon everyone and welcome to our final paper presentation session of Cyber Science 2020 for track 17, Emerging Technologies and IoT and Bots. We just have one paper in this session today and then we're straight into the close and plenary session, which should last for a half an hour as well. So our presentation today, we're lucky we're going to have a tag team act from Maicon and Morgana, and they're going to present their paper entitled Application and Analysis of Record Linkage Techniques to Integrate Brazilian Health Databases. So guys, whenever you're ready, over to you. As always, if there's any questions, pop them in the Q&A and we'll handle them at the end of the presentation. Thanks.
Okay. Hello everyone. My name is Lino. I am PhD student at Universidade de Pernambuco in northeast of Brazil.
And I am Morgana Leite, undergraduate student at Universidade de Pernambuco, Brazil.
So I will present to you the work entitled Application and the Analysis of Record Linkage Techniques to Integrate in Brazilian Health Database. My colleagues in this work are Vanderson Sampaio, Thalita, and Patricia Endo, professors. In partnership with Universidade de Pernambuco, Brazil, Fundação de Medicina Tropical, Brazil, and the Dublin City University, Ireland.
According to the World Health Organization, tuberculosis is one of the 10 diseases that kills the most in the world. Tuberculosis is also one of the main causes of death for HIV-positive people. Because of that, tuberculosis has been a mandatory reporting disease in Brazil since 2001. This means that cases must be reported to the Brazilian government when they occur, so the researchers can identify disease trends and predict epidemics.
So in Brazil, the federal government is responsible for maintaining and update several health databases. In this work, we use two health databases related to clinical and demographic data regarding to tuberculosis cases from 2007 to 2018. So collected in the state of Amazonas. The Brazilian government is responsible for the database SINA, that means Information System for Notifiable Disease, which contains data on patients diagnosed with mandatory reporting disease, and the SIN, that means the Mortality Information System, which contains data on mortality. So the databases are protected by Brazilian law, and the data obtained in this work were authorized by the Ethics Committee.
Before we did our research, the SINA had more than 30,000 tuberculosis cases registered. From those, more than 1,000 were tuberculosis deaths. In the SIN, the total of deaths in general were more than 200,000. From those, more than 2,000 were tuberculosis deaths. It is widely agreed that this data does not reflect the true number of fatality records, as many records are not updated on SINA when the patients die. The data from SINA and SIN databases do not have a unique identifier. This makes integration very difficult. For example, if we need to know the patients hospitalized for tuberculosis and who died from tuberculosis, we do not have this information integrated.
So, this work in progress presents the application and analysis of two record linkage techniques, SONDEX and the GERO, for integrating the two Brazilian health databases, SINA and SIN, related to tuberculosis cases. So these databases are mentioned previously, are in the domain of the federal government, and they do not have a unique identifier. Therefore, it is necessary to integrate the two databases so that the same person registered in one database is identifier in the other database. For that, we have only a few attributes available that will be present below. We plan to use the new integrated database as an input to computational model to predict the probability of the mortality death by tuberculosis.
But what is record linkage? Record linkage is a process of identifying a set of records that belong to the same entity, being in the same database in case of duplicated data, or in different databases, which is our case. We used Sondex and Zero for that. Sondex is a phonetic coding algorithm which uses rules to encode words according to their pronunciation in the English language. Sondex encodes homophones in the same way, so words with a similar sound can be matched despite being spelled differently. I brought to you this quick example. Here we have two words, John and John. They have the same pronunciation, however, they are spelled differently. The first John does not have a H, while the second does. When we apply Sondex to those two words, they have the same encoding because of their similar pronunciation, despite being written differently.
On the other hand, the JIRO is a partner match recognition technique, which compares words using statistical analysis related to the distance between the matches of two strings. So where model S1 and the model S2 is the length of the strings S1 and S2 respectively. M is the number of character matches between model S1 and model S2. And the T is the number of transposition, that is the characters that were exchanged. For example, do a typo search as SA and AS. The statistical distance between the similarity of string threshold was 85%.
To use the record linkage techniques, we organized the SIN and SINAN columns the following way: patient's full name, patient's first name, patient's last name, patient's mother full name, patient's mother first name, patient's mother last name, patient's date of birth, and patient's gender. We applied the techniques to all the columns, except the patient's date of birth and gender. If 7 or more of those criteria match, they are considered a potential match.
So both databases have data problems in which names are written differently, and they also have typos. These problems make the integration of the bases difficult, and they can be solved with the application of record linkage technique, or also known as data match. In this example, the name Maicon is at the base of SIN, and the Maicon and the Maicon 2, the same person, the name typed incorrectly, is in the SINAN database. So the same person may be in SINAN more than once due to treatment abandonment. So when this person returns to treatment, a new registration is performed in this system without any link to the previous registration. The record linkage techniques indicated these strings as being a single unit of real life that is unify the record. So the same, in these cases, the same person, the same name, mother's name, birth name, and gender. And in this example, we demonstrate how the Sondex and the JIRO technique work in practice. It is worth remembering that in this example, it is possible to find in the SINAN database two records for the same person. In this case, the patient abandoned the treatment, and when he returned, A new record was made in this system without any link to the record preview. We can notice that the phonetic encode Sondex has a similarity between all fields in the table. For example, the full name, Maicon, Lino, and the SIN database have the Sondex M254 code. While the full name, Maicon, Lino, in the SIN have the same code. And then finally, Maicon, Lino has the same code too in the SIN. Therefore, this column through the Sondex technique is matched. Thus, all other columns follow the same comparison. In the Jadon technique, we used 85% threshold. So if any of the columns have similarity equal to or greater than 85%, then we consider it's a match for that column. In this example, all columns have a value equal to or greater than 85%, with the exception of the first name column here, okay, which was 78% similar that for this column within Jadon technique. There was no match between the pairs of candidate record. But as we can see in the table, 8 criteria were used. However, we consider that there was matching from the record when we found 7 or 8 criteria satisfied. So for this example, the SIN record had matched with 2 SIN records. That is the same person or entity in the real world was recognized. Continuing, Sondex identifier 1,812 potential matches in the Jadon 1,830. Of these potential matches, Sondex presented 54 false positive, while Jadon returned 8 incorrect matches. Jadon showed better results than Sondex, with the final results 1,805 real matches for the Jadon, in the 1,758 for Sondex. The records identifier as false match were verified individually. When the researcher identified that the pairs of match were not the same entity in real world, the records were classified as false match.
Compare the results using the record linkage techniques with the 2,866 tuberculosis cases registered at the SIN database. Jadon presented the best performance, discovering 581 new records, while Sondex was able to identify 534 new records. As next steps, we plan to apply and compare all the record linkage techniques. For example, metaphony, that is not a phonetic coding like Sondex, and Jadon-Winkler, a variation of Jadon. And we also focus on the Brazilian Portuguese language, utilizing Sondex BR, a variation of Sondex. Thanks.
So that is, does any have any question?
Thank you guys for that. Very interesting. Do we have any questions? So he said, thanks for a great presentation. Are you aware of commercial products not in the academic domain that specialize in this type of data matching?
Maicon, did you want to say?
No. Grace, please, can you send me the question in the text in the chat, please?
Yeah, so you should be able to see it there, Maicon, in the Q&A.
Okay.
Products.
So if you click on Q&A, you should be able to see the question.
The techniques. I don't.
Do you see at the bottom of your screen Q&A? No? Hold on, let me send it on to you now. 1 second.
So we did not search for commercial products. DQA, ok. Encontrei aqui agora.
Okay, so I guess Patricia has given kind of an answer there that it could be something that you guys look at in the future going forward with the project. Okay, so we'll move on because we do have another question. So Everest has said, thanks to your great work and presentation, can you highlight any ethical issues and challenges you face in this current project in Brazil?
We cannot show any of the names in the database because they are confidential data. I don't think so when in the first version of this paper, when we want to show in case of the presentation, when we show an example of how we did the techniques, we cannot show real data, so we use our own names because of that.
Yeah.
And we received the ethical approval to utilize this data.
Which I'm sure is hard enough to get that kind of ethics approval. But it's still important work all the same. So when you publish the papers as well, any examples you use, I assume you use fake names. Would that be correct?
Yes, when we did in our presentation, we used fake names because of that to show how we use our techniques. We cannot use a real example of how those techniques work because of that, the private data.